Hello my dear students, here is again your computer Bunsam, and today I want to show you what you can do with arithmetic values and calculations. But first again we need some variables here. Let's give it int first, second and int third. Let's say first equals 11, second equals 6. And int third is unassigned because we are using again our variable to be assigned in runtime. Let's say third equals first plus second. As you can see, it is just a simple arithmetic expression, and we can just write it down by console.writeLine. Brackets open, third, and then as soon as we press 1, you can see that the calculation will be 17. As simple as that. You also can do these calculations with some other operations like minus and with multiplications. So yeah, 11 times 6 is 66. So yeah, this seems simple, but this is only a small part of the possibility to create these special calculations which are necessary for modern programming. So let's start with one of the more interesting facts of arithmetics, the increments. So what happens when I write down third plus plus? You see the value will be 67. Let's do it again. Third plus plus. It's 68, yeah? And then if I add it again, third plus plus. Nice. Then we get 69, yeah? The interesting thing about this plus plus is that it increases the value of your operation by 1, of your number by 1. So for instance, if we have 27 and they say 27 plus plus, then we'll get 28. There are multiple different possibilities to create these increments. Here, for instance, if I say plus plus third, it is the same as third plus plus. However, if I delete this one and again add this one, you will see the same value. If I add the pluses, however, behind the third, you will see it will be 68. The reason for this is that these ones, where third plus plus is there, increase the increment only at the ending of the operation. So for instance, if we have third plus plus, then up to this point, it is 66, then it goes to 67. Then in this case, here it is still 67, then it goes to 68. And here in this case, while we write the line, it is 67, but at the end it will be 69. The increment operations are mostly used for special loops called for loops, which are necessary to create some interesting programming techniques. There's another way to do this too. I delete them and now say minus minus. This is a so-called decrement operation. So if we have 66 here, 11 times 6 is 66, and then we use the decrement operation, then we will get 65 instead. So the reason for this is that the decrement reduces the value by 1, and it is the same point for this like the increment, that it depends on the position of the minus minus on when it will be used. These are just some examples of usage in increment and decrements. I will keep it like this with 67 because there are some other operations where you can use some unary values. For instance, if we have some special point where we want to say that third should be increased only by, let's say, second, then we can write it down like this. This here is the same like saying third equals third plus second. Third plus second. This is the same thing here. Let's see what happens. It should be 73. Now let's try it again with third plus equals second. You know, here it is 73. Then we add this one. Then we press 1. Then we will get 79, as you can see. We can do this again and again so that we can use specific values which we can use for our further calculations too. As you can see, there are multiple possibilities to calculate. Here we have the multiplication operator, which is this single star. It's usually the x on the numpad, and yeah, we have the plus operators and the minus operators. Maybe some of you were already very observant that we have lacked our divisional operator. The reason for this is in fact quite simple here. If we have here first times second, I'll delete this rest here, and then yeah, this is okay, and then press 1, then you will get 1. Now wait a second, 11 divided by 6 isn't 1, it's 1.8333. Maybe I should use some other numbers here. Let's say 15 and 6. Now 15 divided by 6 is 2.5, and 2.5 cannot be shown here because we have the integers, and integers are numbers which don't have any point operation, no floating point in this case. To get the floating point values, we technically need another type for this. In our case, let's use double. Now if we press 1, we still only get 2. The reason for this is that these two will be divided by the rules of integer. The integer rules mean that if there are two numbers which will get divided, then they only keep the whole number. So no 0.5, 0.6, no nothing between 0 and 1. So in our case we have 2, not 2.5. To get the 2.5 we need to cast it. Therefore we need to say that this is double, and as you can see we will get 2.5. Typecasting is also something which is used quite often in computer science. However, we'll try to keep it as little as possible. However, as you can see, the division here works, but if I don't cast it, then we only get the 2 value. The point for this is that both of these are necessary in specific context. I will give it back to an int, and the final operation I'm going to show you is the percentile operation. By the way, every operation which has this plus equal can also be used for any other operation like minus equal, times equal, and so on and so forth. It is the same for any other calculation if you insist. So let's get back to our example. We have the percent sign. The percent sign in our case is the so-called modulo, or it's the residue value. Here we get 15 residue 6 equals 3. This means if you divide 15 by 6, then we get 2 and 3 residue. So we have, for instance, 6 to the power of 2 is 12. 15 minus 12 is 3. The point of this is that we can use them for your own programs if you need the residual values, which can be necessary, for instance, to calculate some smaller operations if necessary. So these are now our arithmetic values. They are the same PEMDAS rules like you have learned them in the computer scientific department first plus second times second, for instance. As you can see, 51. 15 plus 36, it's 51. If you have already learned the mathematics about them, like I said, it's the Pender's rules that, for instance, multiplication comes before plus or minus. I thank you for your attendance, and I can't wait to see you create some amazing programs by using this mathematical formulae. Yours sincerely, your Computer Wunsch.